Hello students of class 10. In this video we will discuss chapter 2, that is complex numbers. So you see page number 47, definition of complex number. A number of the form a plus ib where a and b are real numbers and I is equals to root over -1 is called a complex number. Usually a complex number is denoted by z. Therefore, z is equals to a plus ib, a comma b belongs to R, and I is equals to root over -1 is a complex number. The set of complex numbers is denoted by C. Therefore, C is equals to a plus ib such that ab belongs to R and I is equals to root over -1 is the set of complex number. The symbol Z, which can stand for any of a complex number of C, is called a complex variable. In Z is equals to a plus ib, a and b are respectively called the real part and the imaginary part of Z. These are denoted by a is equals to real part of Z is equals to Re, a plus ib is equals to Rez, b is equals to imaginary part of Z is equals to Im, a plus ib is equals to Imz. A few examples of complex numbers are 2 plus I3, minus 3 plus I5, 3 by 2 plus I minus 5 by 7, etc. If a is equal to 0, in z is equals to a plus ib, then z is equals to ib is a purely imaginary number. For example, 6i minus 3 by 4i, I root 5 are purely imaginary number because in here the real part is 0. Next, if b is equals to 0, in z is equals to a plus ib, in the complex number, if the imaginary part is 0, then z is a real number. For example, a real number, say 5, can be expressed as 5 is equals to 5 plus I0, where imaginary part is 0. Number 3, clearly if alpha belongs to R and alpha is equals to alpha plus I0, which is in the form of complex number, therefore all real numbers are included in the set of complex numbers, and hence we can say that the set of real numbers is a proper subset of the set of complex numbers. Symbolically we write R is a proper subset of C. The numbers minus 6, 3 by 2, 0, etc. are expressed in complex form respectively as minus 6 plus I0, 3 by 2 plus I0, 0 plus I0, etc. So now, what are complex numbers? You see, complex numbers. What are complex numbers? Now we have learned about rational number, irrational numbers, a whole number, natural number, whole numbers, natural numbers, then again integers, fractions. These all numbers we have learned. Now in this chapter we will learn about complex numbers. Now what are complex numbers? These numbers are of the form a plus ib. Okay, this is a complex number, a plus ib. Okay, now this number, it has got two parts. One, it is the real part, and the another b, it is the imaginary part. The number that is multiplied with this I, that number is the imaginary part. Okay, in here a and b belongs to R, that means a and b are real numbers, and I, it is the imaginary number, and I, it is the imaginary number. Okay, and a complex number can be denoted by a complex variable z. Remember, any complex number we can denote it by z. So a plus ib, I can write it as z is equals to a plus ib. Okay. So now what we have learned, that what are complex numbers. these numbers take the form of a plus ib. Understand? It has got two parts. One is the real part and the another is the imaginary part. And in here a and b are real numbers and I is the imaginary number. And the value of I, it is equals to root over -1. Okay, the value of I, it is equals to root over -1. And a complex number can be denoted by a complex variable z. So I can write a plus ib, I can write it as z is equals to a plus ib. Okay, so in here the real part, which is a, it can be written as it can be written as re. Okay, re a plus ib. A, which is the real part, I can write it as re a plus ib, or I can write it as rez. Okay, rez denotes the real part of the complex number a plus ib, and b, which is the imaginary part, I can denote it as I am a plus ib, or I can write it as I am z. I am z means it denotes the imaginary part of the complex number. Rez means it denotes the real part of the complex number. Okay, now next it is that in here it is saying, you see, if the real part is 0, if the real part is 0 in the complex number a plus ib, in the complex number a plus ib, if the real part is 0, then z is equals to ib, because a is 0, so z is equals to ib. Okay, is a purely imaginary number. Okay, is a purely imaginary number. Okay, then z, if in the complex number, if the real part becomes 0, okay, then it becomes a purely imaginary number. In the complex number, if the real part becomes 0, then it becomes a purely imaginary number. Okay, for example, 6i minus 3 by 4i, I root 5 are, these type of numbers are purely imaginary numbers, because in here the real part is 0. And in the complex number, if the imaginary part is 0, then z becomes a real number. Understand? So in the complex number, if the real part becomes 0, then the complex number becomes a purely imaginary number. These are some of the examples of purely imaginary number. Becomes a pure imaginary number. Okay, these three numbers are examples of pure imaginary number. And in the complex number, if the imaginary part becomes 0, then the complex number becomes a real number. Okay, because in here b is 0, so z is equals to, it will become a, so z becomes a real number. For example, real number, say 5. Now 5, it can be expressed in form of a complex number. I can write 5 as 5 plus I0, where the imaginary part is 0. So clearly, if alpha belongs to R, then alpha, this real number, I can write it as that real number plus I0, which is in the form of a complex number. Therefore, all real numbers are included in the set of complex numbers, and hence we can say that the set of real numbers is a proper subset of the set of complex numbers. That means all the real numbers are included in the set of complex numbers. That means real numbers, I can write them in the form of complex numbers. Understand? So -6, 3 by 2, 0, etc. are expressed in complex form respectively as -6 plus I0, 3 by 2 plus I0, 0 plus I0, etc. I hope you have understood. So you see, what are complex numbers? Complex numbers, it takes the form of this a plus ib. It has got two parts, real part, imaginary part. In here a and b are real numbers and I is the imaginary number, and its value is I is equals to root over negative 1. And this complex number, I can denote it as Z. I can denote this complex number as Z. So I can write Z is equals to A plus IB. And the real part of the complex number, I can write it as RE A plus IB or REZ. And the imaginary part, I can write it as I am A plus IB or I am Z. Understand? And in the complex number, if the real part becomes 0, then the number becomes pure imaginary number. Understand? And in the complex number, if the imaginary part becomes 0, then it becomes a real number. I hope you have understood. Complex numbers as an ordered pair of real numbers. We have already stated that Z is equals to A plus IB is a complex number where A and B are real numbers and I is equals to root over negative 1. Therefore, we can say that a complex number A plus IB is known if and only if the real numbers AB are known. Okay. So since the position of A and B in the term A plus IB are fixed, so the complex number A plus IB can be represented by ordered pair AB of real number. Here the first component represents the real part of Z and the second component represents the imaginary part of Z. So thus A plus IB is equals to, I can write this complex number in ordered pair is equals to A comma B. So you see 2 plus I3, I can write it as 2, 3. Okay. 6 is equals to, I can write it as 6 plus I0 is equal to 6, 0. I can write them in ordered pairs, etc. We also know that 1 is equals to 1 plus I0 is equals to 1, 0. I is equals to 0 plus I1 is equals to 0, 1. Further, we can express Z is equals to A plus IB with the help of notation of ordered pairs for 1 and I as below. So Z is equals to A plus IB is equals to A into 1 plus IB. So this Z, I can write it as A bracket start 1 comma 0 plus B bracket start 0 comma 1. Okay. So with the form of ordered pair, the set of complex numbers is represented in the set notation as C is equals to AB such that A belongs to R, B belongs to R. So you see complex numbers as an ordered pairs of real numbers. So we can say that a complex number A plus IB is known if and only if the real numbers A plus IB are known. Understand? Since the positions of A and B in the form A plus IB are fixed, so the complex number A plus IB can be represented by the ordered pair AB of real number. Here the first component represents the real part of Z and the second component represents the imaginary part of Z. Okay. So the complex number A plus IB can be represented by ordered pair AB where A represents the real part and B represents the imaginary part of Z. So A plus IB, I can write it as is equals to AB, and these are examples given. -3 minus 5i, I can write it as -3 comma -5. We also know that 1, I can write it as 1 plus I0. So its ordered pair will be 1, 0. And I can write it as 0 plus I dot 1. Its ordered pair will be 0, 1. Understand? So Z, you see Z is equals to A plus IB. So it can be written as A bracket start 1, 0 plus plus B bracket start 0, 1. So with the form of ordered pairs, the set of complex numbers is represented in the set notation as C is equals to AB such that A belongs to R, B belongs to R. Okay. Example 1, express a plus ib, express in a plus ib form and then represent as ordered pairs. So first it is our given example 1, express in a plus ib form, express in a plus ib form first, minus 2 by 3. This I have to express in a plus ib form. Okay, no problem. So in here, this I can write it as minus 2 by 3 plus I dot 0. Imaginary part is 0 here. Understand? Which is in a plus ib form, and minus 2 by 3 plus I dot 0. If I want to write this complex number in ordered pair, I can write this is equals to minus 2 by 3 comma 0. This is our answer. Understand? Next again, number 2, you see 3 minus I root over minus 16. So in here 3 minus I root over minus 16. I have to express it in the form of a plus ib. So in here you see solution. So 3 minus I root minus 16. This I can write it as 3 minus I root minus 1 into 16. So this becomes 3 minus I root minus 1 into root over 16. So this, it becomes 3 minus I root over negative 1, its value is I, so into I into root over 16, it becomes 4. So now this becomes 3 minus 4I square. So 3 I value, it is root over minus 1, so I square, its value is minus 1. So minus 4 into minus 1, this becomes 3 plus 4. This becomes is equals to 7. So 7, I can write it as 7 plus I dot 0, which is in a plus ib form, And if I want to write it in ordered pair, I will write 7 plus I dot 0 is equals to 7 comma 0. Next, number 3, root over negative 9 plus 5 by 7. So I have to represent it in the form a plus ib, and then I have to represent as ordered pairs. So now you see this minus 9 plus 5 by 7, I can write it as minus 1 into 9 plus 5 by 7, minus 1 root over minus 1 into root over 9 plus 5 by 7. So this becomes I, and this becomes into 3 plus 5 by 7. So this I can write it as 5 by 7 plus I dot 3, which is in the form a plus ib, and also 5 by 7 plus I dot 3, this is equals to 5 by 7 comma 3. I can write this is in the form of a plus ib. I can write it in ordered pairs. So this becomes is equal to 5 by 7 comma 3. So in here, before we proceed further, so you see definition, pure imaginary numbers. If a be a positive real number, then the number root over negative a is called a pure imaginary number. Here root over negative a is equals to root over minus 1 into a. Now this I can write it as is equals to root over negative 1 into root over a. Root over negative 1, it becomes I. So this becomes is equals to I root over a is an imaginary number where root over a is real. A real number when multiplied by I give rise to a pure imaginary number. I is equals to root over negative 1 is called the imaginary unit. Okay. So next you see operations with imaginary number. The rule root over a into root over b is equals to root over a into b is not valid if both a and b are negative. Okay, very important. So root over minus 3 into root over minus 5 is equals to this I cannot do here. Root over minus 3 into minus 5, this is equals to, it becomes root over 15. This I cannot do here. What I will have to do, from here root over minus 3, I will have to separate this negative. Root over minus 1, I will have to separate it. So if I want to do, you see here, root over minus 3 into root over minus 5, this I cannot do here, into is equals to root over 15. This thing I cannot do. Instead of doing this, I will have to do is equals to, this becomes root over minus 1 into root 3. By root over minus 3, it will become root over minus 1 into root over 3 into, again root over minus 5, it becomes root over minus 1 into root over 5. Root over minus 1, it is I into root 3. Root over minus 1, it is I into root 5. So this it becomes I square into root 3 into root 5. So I square means minus 1. So it will become minus 1 into, now you see 3, both are positive, 3 and 5 both are positive here. So now I can do this, 3 into 5. So it becomes negative root 15. You see this is negative root 15. And next it is I square value is minus 1 and I cube value it becomes minus I, and then next it is I to the power 4 it becomes 1, I to the power 5 it becomes I, or I to the power 5 I can I to the power 5 it is I can either find out in this way or I can find out in this way. So in general, if n is positive integer, then I to the power 4n it becomes 1, I to the power 4n plus 1 it becomes I to the power 4n plus 2 it becomes minus 1. For negative integral powers of I, we have the following: I to the power minus 1 it is minus I to the power minus 2 it is minus 1, I to the power minus 3 it is I to the power minus 4 it is 1. So in general, I to the power minus 4 I to the power minus 4n it becomes 1, I to the power minus 4n plus 1 it becomes minus I to the power minus 4n plus 2 it becomes minus 1, etc. It is evident from the above discussion that all even powers of I are real, whereas all odd powers of I are imaginary. Okay, so you see example 1, simplify the following. So how do we simplify the following? Example 1. So you see example 1, simplify the following. Number A, root over minus 9 into root over minus 16. Remember this I cannot do this. Minus 9 into minus 16, this I cannot do. Okay, so what I will do, first of all, I will separate root over minus 1. I will separate it from here. So this I can write as minus 1 into 9, into this I can write as minus 1 into root 16. So this becomes I root 9 into I root 16, which I dot 3 into I dot 4, 12 dot I square. So this becomes minus 12. This is the answer. I hope you have understood. Next, again, you see number B. Number B, I to the power minus 243. So I to the power minus 243, this becomes 1 by I to the power 243. So now you see 243. So is equals to, this I can write it as I to the power, always try to this power, always try to make this power an even number. Okay, always try to make this power an even number. I to the power 243. Now this is an odd number, always try to make I power an even. So this thing I can write as 242 dot I. Okay, always try to make this power an even number. So therefore this again is equals to, I can write 1 by I to the power, you see 242, if I divide it by 2, 2 ones are 2, 2 twos are 4, 2 ones are 2. So it becomes, I can write this I to the power 242, I can write I to the power 2 to the whole power 121, I can write it again dot I. Okay. So 1 by I to I square, it becomes minus 1 to the whole power 121 dot I. Now this is negative 1 to the whole power 121, which is odd, so negative will remain, it will remain negative 1 only, dot I. So this becomes 1 by negative I. Okay, so now you see both the numerator and the denominator, I will multiply it by I. So 1 dot I by minus I dot I. So is equals to, it becomes I by minus I square. So is equals to I by minus I square, it becomes minus 1. So this becomes I. So this is our answer. Okay. Next it is number C. Next it is given number C. 1 plus I to the power 4, 1 plus 1 by I to the power 4. So now 1 plus I to the power 4, 1 plus 1 by I to the power 4. So this is equals to 1 plus I to the power 4, 1 plus, in here both I will multiply to, so it becomes I by I square to the whole power 4. 1 plus I to the power 4, I square means minus 1, so it becomes 1 minus I to the whole power 4. So this I can write 1 plus I, 1 minus I to the whole power 4. This thing I can write is like that. This is a plus b into a minus b formula. It becomes 1 square minus I square to the whole power 4. So this is 1 minus I square is minus 1 to the whole power 4. So again this becomes 1 plus 1 to the whole power 4. This becomes 2 to the power 4 is equals to 16. This is our answer. So I hope you have understood. Next we will start exercise. Next we will start, you see, exercise 2.1 we will start. Okay, and rest you see in here, operations of complex numbers. These things we will learn when we will do our exercises. Exercise 2.1, type 1, identify the imaginary numbers from the following. Number A, root over minus 9. So I have to identify whether it is an imaginary number or not. So you see, this one I can write as this root over 9. So this becomes I dot 3. So which is an imaginary, I can say, which is an imaginary number. Okay. Next, number B, root minus 7 into root 5. So this is again solution. This one I can write it as minus 1 into 7 into root 5, minus 1 into root 7 into root 5. This becomes I into, now this I can do 7 into 5, I into root over 35. So this is I root 35. So which is an imaginary, number, which is an imaginary number. Next again you see, it's an imaginary number. Next again you see, number C, it is root over minus 3 into root over minus 4. This one, remember, I cannot do like that. Minus 3 into minus 4, this I cannot do. Okay. So this is root over minus 1 into 3 into root over minus 1 into 4. Root over minus 1 into root over 3 into root over minus 1 into root over 4. So this becomes I root 3 into I root 4. I root 3 into I dot 2. I into I square into 2 root 3. This becomes minus 1 into 2 root 3 minus 2 root 3, which is not an imaginary number, because in here, which is not an imaginary number, because this is a real number. In here there is no I, so it is not an imaginary number. So rest of the problems I have already given you in the notes, or recently I have given you the video of exercise 2.1. Rest of the problems you look it from there. So next we will go type 2, which is simplify. Number 1, you see I to the power 35 plus 1 by I to the power 31. So in a simplify, I will have to simplify. So one thing you remember, I power, you will have to bring it to an even number. In an I power, you see odd number there. I power, you will have to bring it to an even number. So to do it, you see I to the power 35, I can write I to the power 34 dot I. Okay. Then plus 1 by I to the power 30 dot I can write it like that. Now this I to the power 2 to the whole power, 34 if you divide it by 2, 2 1s are 2, 1 4, 2 7s are 14, so it becomes 17 dot I plus 1 by I square to the whole power 15 dot I square, it is minus 1 to the whole power 17 dot I plus minus 1 to the whole power 15 dot I. This power odd there, so it will remain minus 1 only. Minus 1 dot I plus 1 by minus 1 dot I. So this becomes minus I minus 1 by I. In here, 1 by I, both side I will, you see, minus 1 into I by I into I. Both side I will multiply to. So I will get is equals to minus I by I square minus 1 minus I by I square is minus 1. So this it will go. So ultimately you will get minus I plus I, which will be equals to 0. So this 0, I can write it in A plus IB form. So let me check the answer. Simplify, do for. Let me check the answer here. 2.1. Exercise 2.1. Exercise 2.1, type 2 number 1, you see 0. So you keep it like that, 0. Understand? Next again you see 1 plus I square, 1 plus I the whole square. So this again you see 1 plus I, 1 square plus I square plus twice I, 1 plus I, 1 minus 1, I square is minus 1, so it will become minus 1, plus twice I. So 1 plus I, this is 0, so twice I. This if you multiply it with 1 plus I, you will get twice I plus twice I square, twice I. This I square means minus 1, so it will become minus 2. So you can write this as minus 2 plus 2y. Okay, let's check the back answer. Exercise 2.1. It is 2 bracket minus 1 plus I. Okay, you can write this 2 bracket minus 1 plus I. This is your answer. So next again you see number 3, 1 plus I square, 1 plus I cube, 1 plus I to the power 4. So this one you see it becomes 1 plus I. This it will become 1 minus 1. I cube, you see I cube we have already learned here. You see if I cube there, I cube, then it is minus I. So therefore 1 minus I, and I to the power 4. I to the power 4, you see it is 1. I to the power 4, it is 1. So 1 plus 1. So 1 plus I into 0 into 1 minus I, and this is into 2. So ultimately it becomes 0. So rest of the problems you see how I have done. If you have got any doubt or any problem you are not able to do, you can write it in the comment section. Next you see type 3, express each of the following numbers in A plus IB form. Type 3, express in A plus IB form. Express in A plus IB form. Number 1, 2 minus root over minus 5. Okay, so this one I can write 2 minus 1 into 5. 2 minus, this one I can write it as minus 1 into root over 5. So this becomes 2 minus I root 5. So 2 plus I bracket minus root 5. This is our answer, A plus IB form. Okay, A plus IB form. Let's check the back answer. A plus IB form. you see 2 plus I root 5. Okay, 2 plus I root 5. So next you see number 2, root over minus 3 minus root 3. Okay, so next number 2, root over minus 3 minus root 3. So this again I can write as I root 3. Yes, this I can write as I root 3 minus root 3. So this A plus IB form. So minus root 3 plus I root 3. This is my answer. Next you see 3. 2 into root 2. 2 into negative 2 into root over minus 2 into root over minus 1. So this I can write it as 2 into I root 2 into I. So this becomes I square into 2 root 2. So minus 1 into 2 root 2. So minus 2 root 2. So this you can write it as minus 2 root 2 plus I dot 0. This is A plus IB form. Understand? So similarly, rest of the problems you see, you can look from the notes that I have given, or you can look at the video that I have posted yesterday. From there you can see. Now we will go to type 4. Type 4, evaluate the following. Type 4, evaluate the following. Number A, I to the power 19 plus 1 by I to the whole power 25 to the whole power 3. So again, I to the power 19, there I can write I to the power 18 dot I plus this I can write as 1 by I to the power 25 to the whole power 3. So this I to the power 2 to the whole power 9 dot I plus I to the power 24 dot I to the whole power 3. This becomes minus 1 to the whole power 9 dot I plus I to the power 2 to the whole power 12 dot I. Next it is minus 1 to the whole power 9, it becomes minus 1. So minus I plus 1 by minus 1 to the whole power 12 dot I to the whole power 3. Again minus I plus, this is minus 1 to the whole power, and even number there, so minus it will, I will not write minus again. Understand? It will become positive. So I will get 1 by I to the whole power 3. Now minus 1 plus this 1 by I, it becomes I by I square. Okay, I by I square to the whole power 3. So this becomes minus I because I square it is minus 1, let me write it, plus I by minus 1 to the whole power 3. So this becomes minus 1 minus I to the whole power 3 minus twice I to the whole power 3. So this becomes minus 8I cube. Yes, minus 8I cube. So is equals to minus 8 into I cube. It becomes, you see, I cube, it becomes minus I. So into minus I, ultimately it becomes 8I. This is our answer. Understand? Let's check the back answer. 4 type, this is 8I. Okay, you one time you check it from the notes that I have given, or you can check my previous video. So rest of the problems you try to do by yourself. If you get any doubt or you're not able to do, you please write in the comment section. In the next video, again I will show you how to do. Next, number 5. Find the smallest positive integer n for which the equality is satisfied. So first of all, I will take that 1 plus I to the power twice n, it is equals to 1 minus I to the power twice n. So this one I can write it as 1 plus I to the whole power 2 to the whole power n is equals to 1 minus I to the whole power 2 to the whole power n. Now this you will have to break into a plus b the whole square formula. 1 square plus I square plus twice I to the whole power n. This is equals to 1 square plus I square minus twice I to the whole power n. Plus twice I to the whole power n. This is equals to 1 minus 1 minus twice I to the whole power n. Twice I to the whole power n is equals to minus twice I to the whole power n. Now this you see, I can write this as 2 to the power n to the whole power twice I to the whole power n is equals to this one. I can write it as 2 by I to the whole power n minus this one. You see 2 by I into I if I do, I will get twice I by I square, which becomes minus twice I. Yes, so therefore minus twice I can write as 2 by I. So this becomes to the whole power n. Now this one I can write as 2 to the power n into I to the power n is equals to 2 to the power n by I to the power n. So from here 2 to the power n, 2 to the power n I can cut. I will get I to the power n is equals to 1 by I to the power n. I to the power n, if I send it this side, I will get I to the power n to the whole square is equals to 1. I to the power twice n is equals to 1. So this one you see, I to the power twice n is equals to 1. 1 I can write it as I to the power n is equals to I to the power 4 I can write. 1 I can write as I to the power 4. Okay. So because you see I to the power 4, it gives me 1, and it is the smallest positive value. Okay, it is the smallest positive value for which n I to the power n, this is equals to 1. Okay, or you can say that the smallest positive value of n for which I to the power n becomes 1, it is n value, it will be 4. Okay, so therefore 1, in place of 1 I will write I to the power 4. So ultimately I will get twice n is equals to 4, n is equals to 4 by 2, n is equals to 2 I will get. Understand? So therefore find the smallest positive integer n for which the equality is satisfied. The smallest positive integer n for which the equality is satisfied. So 1 in here you see I to the power twice n is equals to 1. So I to the power twice n is equals to, I can write 1, I can write as I to the power 4. Understand? Next, number B. For positive integer n, so that this is equals to 2 to the power n. Yes, number B. So in here you see 1 minus I to the whole power n, 1 minus 1 by I to the whole power n is equals to twice n. This one I will have to prove. So therefore I will take LHS 1 minus I to the power n, 1 minus 1 by I to the power to the whole power n. So in here I will get 1 minus I to the power n, this I in the denominator there, so I can write it as 1 minus I by I square to the whole power n. So 1 minus I to the power n, this becomes 1 minus I by minus 1 to the whole power n. So 1 minus I to the whole power n, 1 plus I to the whole power n. So this one I can write as 1 minus I, 1 plus I to the whole power n. This ultimately becomes 1 square minus I square to the whole power n. This is 1 minus minus 1 to the whole power n. So 1 plus 1 to the whole power n. This becomes 2 to the power n, which is equals to RHS. This is our proved. Okay. So next you see, next number 6. Question number 6. Find Z1 plus Z2, Z1 minus Z2, Z1 into Z2 and when Z1 and Z2 are given as. So number 6, first Z1 it is given as Z1 is equals to 3 minus 4i and Z2 it is given as minus 2 plus I. So first of all I will have to find Z1 plus Z2 I will have to find. So Z1 plus Z2 is equals to 3 minus 4i plus minus 2 plus I. So 3 minus 4i, this becomes minus 2 plus I. So this is equals to, so real part I will subtract 3 minus 2 and 3 minus 2 minus 4i plus I is equals to 1 minus 3i. This is the answer. Next again number B, Z1 and then again this is your first. Next I will have to find Z1 minus Z2. So 3 minus 4i minus minus 2 plus I. 3 minus 4i plus 2 minus I. 3 plus 2 minus 4i minus I. 5 minus 5i. This is your answer. Next number 3. Z1 into Z2. 3 minus 4i into minus 2 plus I. So this becomes 3 minus 2 plus I. Minus 4i minus 2 plus I. So this it becomes minus 6 plus 3i. 4 to the 8i minus 4i square. So minus 6, this becomes 11i plus 4. So minus 6 plus 4, you will get minus 2 plus 11i. This is the answer. And next I will have to find Z1. Okay, so these three. Z1 plus Z2, I will get 1 minus 3i. Z1 minus Z2, 5 minus 5i, and this is minus 2 plus 11i. Let's check the back answer. Number 6, 1 minus 3i, 5 minus 5i, minus 2 plus 11i. Okay. So similarly, rest of the problems you try to do by yourself. Next again you see, let's do number C. Let's do number C here. So number C, it is given Z1 is equals to 1 by 2, 3 minus 5i, and Z2 is equals to 1 by 3, 4 plus 3i. So Z1 plus Z2 is equals to 1 by 2, 3 minus 5i plus 1 by 3, 4 plus 3i. So this becomes 3 plus 2 minus 5 by 2i plus 4 by 3 plus I. So 3 by 2 plus 4 by 3 minus 5 by 2i plus I. So this one, if I take the LCM here, 6 I will get. 9 plus 4 to the 8 and plus, if I take LCM here, I will get 2 minus 5 plus 1 and bracket I can give. This one I can give. So next I will get 17 by 6 plus this I will get minus 4 by 2 I. You write this in bracket. So ultimately I will get 17 by 6 minus 2i. Let's check the back answer. 17 by number 6, number C. 6 number C. 17 by 6 minus 3 by 2i. Did I make a mistake here? 4 by 3. 4 by 3. This will be minus 5 by 2. 1 by 3 into 3i, it becomes I. Okay, everything correct there. Minus, oh sorry, this will be 2. Sorry, this will be 2. Okay, so in here, it becomes 5, it becomes minus 3. So this was a mistake I have done. So minus 3 by 2 I. This is the answer. 17 by 6 minus 3 by 2 I. Okay, and then next z1 minus z2 I will have to find. So z1 minus z2 is equals to 1 by 2 3 minus 5i minus 1 by 3 4 plus 3i. So this becomes 3 by 2 minus 5 by 2i minus 4 by 3 minus I. Okay, so now 3 by 2 minus 4 by 3 minus 5 by 2i minus I. So this becomes 6. 2 3 is 6, 9. 3 2 4 8, and this becomes plus 2 minus 5 minus 2 I. So this I will get 1 by 6, and this becomes minus 7 by 2 I. And then the last one, z1 into z2, this becomes 1 by 2 3 minus 5i into 1 by 3 4 plus 3i. So this 3 by 2 minus 5 by 2i into 4 by 3 minus 4 by 3 plus I. Okay, so now these two I will multiply to 3 by 2 4 by 3 plus I minus 5 by 2 I 4 by 3 plus I. So this becomes 4 3 is 12 by 6 plus 3i by 2, and this becomes 5 4 is 20i by 6 minus 5 by 2i square. Okay, so now this whole thing I am doing this side. Now you see I will get now you see 12 by 6. This is I square, there it will become minus 1. So minus 1 into minus, it will plus become. So 12 by 6 plus 5 by 2 plus 3i by 2 minus 20i by 6. So now in here you see, if I take LCM, 6 comma 2 2 3 1 3 3 to the 6, LCM 6, 12 plus 3 15, plus 2 and 6, again it will become 6 only. 2 3s are 9i minus 20i. So this one it will become 27 by 6, and this it will become minus 11i by 6. So this one I can write 1 by 6 bracket start 27 minus 11i. I can write this in this way. So let's check it with the back answer, z1 plus z2, number 6c. Let's check it with the back answer. So this one you see 17 by 6 minus 3 by 2i, 17 by 6 minus 3 by 2i, and z1 minus z2, 1 by 6 minus 7 by 2i, 1 by 6 minus 7 by 2 I, and z1 into z2, it is 9 by 2 minus 11 by 6 I. I have got here, okay, 9 by 2 minus 11 by 6. So you see, instead of doing this one I can cut it. I can cut it by 3. So 3 9s are 27 and 3 2s are minus 11i by 6. So this is the answer. I hope you have understood. Next, we will go to Next we will go to question number 7. Okay, next we will go to question number 7. Next you see it is question number 7. Express each of the following complex number as the sum of ordered pairs. Each of the complex numbers as the sum of ordered pairs. Number 1, minus 3 plus 5i. Express each of the following complex number as the sum of ordered pairs. So in here you see this one I can write it as minus 3 plus 5i is equals to minus 3 bracket start 1 comma 0, and this I can write it as okay, first of all this I can write it as minus 3 comma 5, which is equals to I can write it as minus 3 1 comma 0 plus 5 0 comma 1. Okay, next again number 2, 3 plus I root 2. So 3 plus I root 2 I can write it as 3 comma root 2, which is 3 1 comma 0 plus root 2 0 comma 1. Next again you see number 3, minus 4 minus I root 3. This I can write it as minus 4 minus I root 3 is equals to minus 4 minus 4 comma minus root 3, which is minus 4 1 comma 0 plus minus root 3 0 comma 1. Okay, let us check the back answer. Minus 3 1 comma 0 plus 5 plus, and this is minus 4, so this is ultimately it becomes minus 4 1 comma 0 minus root 3 0 comma 1. Okay, so next again 2, number 4 it is there 2, so you see 2 I can write it as in place of 2 I can write it as 2 plus I comma 0, which is it becomes 2 comma 0, 2 bracket start 1 comma 0 plus 0 bracket start 0 comma 1. Next again number 4, 2 plus root 3. So this solution 2 plus root 3 plus I dot 0, I can write it in this way. 2 plus root 3, this is the real part and this is the imaginary part, which I can write it as 2 plus root 3 2 plus root 3 comma 0. So 2 plus root 3 bracket start 1 comma 0 plus 0 0 comma 1. So similarly you see the last it is there, number 6 it is there, 1 by 2 3 plus 5 I it is there, so this becomes 3 by 2 plus 5 by 2 I, which I can write it as 3 by 2 comma 5 by 2, which I can write it as 3 by 2 1 comma 0 plus 5 by 2 0 comma 1. This is, let us check the back answer. Number 7 you see minus 3 minus 3 1 comma 0 plus 5 0 comma 1, and then 3 1 comma 0 plus root 2 0 comma 1, minus 4 1 comma 0 minus root 3 0 comma 1, and this is 2 1 comma 0 plus 0 0 comma 1, 2 plus, this one you can give it bracket, 2 plus root 3 1 comma 0 plus 0 plus 0, it will be 0 comma 1, and the last number 6 3 by 2 1 comma 0 plus 5 by 2 0 comma 1, it is correct there. Okay, now next you see next in here you see question number 8. If x is equals to, question number 8 given, if x is equals to 3 plus 4i and y is equals to 3 minus 4i, then find the following. Following. Number 1, x square plus xy plus y square. Okay, so solution 3 plus 4i, so it becomes 3 plus 4i the whole square plus 3 plus 4i, 3 minus 4i plus 3 minus 4i the whole square. So this becomes your 3 square plus 4i the whole square plus 2 into 3 into 4i plus this becomes 3 square minus 4i the whole square plus 3 square plus 4i the whole square minus 2 3.4i. So this becomes your 9 plus 16i square plus 4 3 is a 12 24i plus 9 minus 16i square plus 9 plus 16i square minus 4 to the 4 3 is a 12 24i. So again this becomes 9 minus 16 plus 24i plus 9 plus 16 I square, it will be minus 1 minus into minus plus become plus 9 minus 16 minus 24i. So plus 24i minus 24i, it will cancel out and then again uh, minus 16 plus 16, it will cancel out. So okay, so in here 9 plus 9 plus 9 uh, 9 8 9 27, I will get 9 plus 9 plus 9 27, 27 minus 16, so 1 1 11 I am getting here. Okay, 11. Let's check the back answer. Number 8, number I. Number 8, number I. Okay, number 8, number I. It is, you see, it is 11 given. Number 8, number I. Number 8, number I. It is 11 given. Okay, next. Next, I will have to find x square minus number 2 x square minus xy plus y square. So you see in here this is also same thing only. Similarly, as I have done x square plus xy plus y square, similarly I can do this also. And number 3, you say x square minus xy plus y square, already I will get the value, and x square plus xy plus y square already I have got, this is 11. So these two values you put it and find question number 3. Question number 4, you see question number 4, it is also nothing there, x cube plus y cube there. So we know solution, we know that x cube plus y cube, this is equals to x plus y into x square minus xy plus y square. So this value we have already got, and x plus y, this one just we have to find 3 plus 4i 3 plus 4i plus 3 minus 4i into this x square, this value whatever you will get, that you will put it in here. So now you see this card, I will get 6 into this value, you put it, you will get the answer. Next, x square minus y square and x cube minus y cube, you try to do by yourself. If you are not able to do, you please write it in the comment section. Next, number 9, you see, if x is equals to 1 minus I, then show that x square minus 2x plus 2 is equals to 0. So solution in here, x is equals to 1 minus I given, I have to show that this is equals to 0. Okay. So x plus I is equals to 1, I can say, and if I square it both side, okay, if I square it both side, x plus I the whole square is equals to 1 square, x square plus I square plus 2xi is equals to 1. So x square minus 1 plus 2xi is equals to 1. So now okay, now what I can do, in here 2xi, it is there, x minus 1, okay, let's see, instead of doing like that, First of all, it is given that x is equals to 1 minus I given. Okay, so let's take LHS. Take x is equal, this is given x square minus 2x plus 2 is equals to, let us put these values here, 2 1 minus I plus 2 1 square plus I square minus twice I. This becomes minus 2 plus twice I plus 2. This 1 minus 1 minus twice I minus 2 plus twice I plus 2. So you see in here, this and this it cancels out, this and this it cancels out, and this it cancels out, which is equals to 0 is equals to RHS. Like this also we can do. Now next again you see question number 10 it is given. Question number 10 it is given factorize. Question number 10 it is given number 1 x square plus y square. I have to factorize this. So now you see x square plus I square, I can write it as minus bracket start iy the whole square. I can write it, okay, this one x square iy, because if I solve this, you see x square minus I square y square it becomes. So x square minus I square is minus 1, so minus y square become ultimately x square plus y square it becomes. So therefore this one I can write it in this way. Okay, so this is this x the whole square. Okay, this is a square minus b square formula, so x plus iy into x minus iy. This is your factorization. Next, number 2, a square minus 1 minus 2ai. So this one you see, you can write it as a square, you can write it as a the whole square plus I square I square minus 2ai, which takes the form of a minus I the whole square, a minus I into a minus I. This is its factorization. So you see number 3 here, I 6 root 2 minus 7. Okay, number 10, number 3 here. So this is our solution. So in here you see this one I can write it as minus 7 plus I 6 root 2. So this one you see minus 7 plus this one I can write it as 2 into 3I root 2. Yes, I can write it in this way. So you see now I minus 7 I can write it as 3I the whole square. Okay, 3I the whole square plus root 2 the whole square plus 2.3I root 2. So this is, you see what becomes if minus 7 if I write in this way, 3I the whole square plus root 2 the whole square. Okay, so this becomes 3I the whole square plus root 2 the whole square. So this becomes 9I square plus, and this becomes 2. So 9I square means minus 9 plus 2. This becomes minus 7. So minus 7 I can write it as 3I the whole square plus root 2 the whole square. So this becomes a square plus b square plus twice ab formula. So 3I plus root 2 the whole square. This becomes 3I plus root 2 into 3I plus root 2. This is your answer. Understand? I hope you have understood. With this, our exercise 2.1 it is over. So exercise 2.1 I have already sent you a video where I have done the problems, and if you have got any doubt you can write it in the comment section. I hope you have understood. Thank you.